All right, so back again. Next lesson, had to take a smoke break. We just did F3, or at least I did F3. F4 is evaluate logarithms. Easy, way too easy. You have a TI-84 in front of you. Ideally, you do this using change of base. I'll show you how to do this on, well, actually, ideally for most of these, you actually understand what the thing is asking. This thing is asking you what power of 9 is 81. What power of 9 is 81? And the answer is 2. I know that 9 squared is 81. Now, you can also go ahead and set this thing equal to something. Kind of figure out what's in the blank. Say it's equal to x. And then do that log is bay thing that we did earlier. That might be the goal as a teacher. Rewrite as a common base. And then you can see it, that the x value is 2. It actually, if you truly understand logarithms, most of these can be done just by asking the question instead of doing the algebra. And I would love if my kids understood this, and I would love if you understood that. So that's where I'd like you to be, whether you're my student or not. And again, I have 29 subscribers. I need 1,000 to get paid. I'm just a poor teacher. Subscribe. All right, evaluate. Write your answer as a whole number, proper fraction, or improper fraction in simplest form. And this one is asking what power of 2 creates a 16. I'm going to keep writing that down for y'all. When I see ones that can be done in your mind, I'm going to write it down. What power of 2 is equal to 16? And the answer to that is 2 to the 4th. Because 16 literally is 2 to the 4th. So I need a 4. Again, I'm going to not do algebra as long as I can get away with it. What power of 5 is 5? What power of 5 equals 5? And the answer is the first power, because 5 to the first is 5 to the first. Easy peasy Japanesey. What power of 7 is 49? 2. Way too easy. What power of 3 is 81? 4. What power of 4 is 16? 2. See how these go? What power of 8 is 64? 2. What power of 6 is 36? 2. What power? Ooh, what do we got here? 8 natural logs of e is what? So somewhere out in the rules of logarithms, you have this one. I don't know how your teachers have taught you. A logarithm, base b, argument a, to the r can be rewritten as r logarithm base b argument a. This is called rewriting exponents as factors because you can shift it out front. So this 8 natural logs of e becomes natural log of e to the 8th. They want to know what it's equal to. Kind of a funky thing. Oh, I'm sorry, it's late at night and I'm being really tired. The answer to this thing is the number 8. Remember that 8 goes out front. I'm going to leave that there. Scratch this train of thought. Okay? Scratch this train of thought. When you talk about the natural log of e, it has an understood base of e. So that piece right there becomes this. Now what this little dude is asking what power of e equals e. It's 1. I have seen so many kids never quite grasp that. But the natural log of e is 1. That's just kind of something you should memorize. The natural log of e is always, 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 always 1. So the answer to this thing is 8. Sorry I took you off down a different path. If you had me for real, you'd understand that. This is log of 100. And if it's not specified, if the base of a log is not given, it is understood. There's that big word in math. We do this a lot. It is understood, which means you are expected to understand that, because I certainly do, to be 10. So when I look at this thing, I see a logarithm of base 10, whose argument is 100, and what it's asking me is what power of 10, because 10 is the base, is equal to 100. And the answer to that is the number 2. This one is asking what power of 2 creates an 8. That's 3. Natural log of e over 10 is going to be 1/10. See that natural log of e? What was it, 2 minutes ago I talked about that? The natural log of e is always 1. Don't believe me? Pull up a TI-84, the thing that you'll accept, and literally type, if mine will turn on, natural log of e to the first. Oh, it's 1. So that thing becomes 1 in 10. Hope you understand it. What level are we at here? It says I'm only at level 2, man. 1 in 10. We got to get better than this. This is just easy peasy stuff. Now, seriously, how is this hard? Log 410. The only way this would be hard is if you had to go old school and use logarithm tables, which is not taught anymore. And they want this thing to what? The nearest, probably thousandth? Yeah, 2.613. 2.613. This is easier than the rest of it. Now, the reason I did that is because there was no power. There's no power of 3 that generates a 42. This one needs to be done. Your TI-84s can actually do this without using change of base, but a logarithm of base b argument a can be done. I always teach one of two things. If you look at any good textbook, they'll say log of a common base of a over log of a common base of b. So what we do here in Dresden, Tennessee, because I teach it here in Dresden, Tennessee, is we use this form. A logarithm base b argument a is equivalent to the natural log of a over the natural log of b. And for students like Cora who just want to do b different than me, log of a over log of b. That's the one she likes. I probably shouldn't call her out by name on something the whole world can see, but you don't have a clue who she is. I didn't say her last name. Very smart young lady, by the way. She just likes to be a little bit different, argumentative. Yeah, so in my TI-84, I'm going to type in ln 42 divided by the natural log of 3. And there we go, 3.402. Haven't seen anything hard, 3.402. Beautiful. All right, going to jump to level 4. That's not a hard question, that's -1. What power of 10 is a 10th? Awesome sauce. What power of 6 creates a -6? You take a 6, raise it to the negative first. Awesome. Natural log of 6.5. That's a calculator problem. Level 5, still not hard, okay? But I did mention something earlier that's going to matter here. Earlier I mentioned that a logarithm base b of a to the r is r log base b a. So what that's saying is I can take the 7, change it from an exponent to a factor. So 7 times 9 is 63 ln e, and ln e is always 1. I don't care who you are. I don't care what you think. Natural log e, b1, 63. So I want my kids taking this thing to a 95, because at 95 they have a semi-decent understanding of evaluating logarithms. So there's another exciting lesson by Mr. Milbrath. And again, I'd like to get paid for this. I'm just kidding. I'm not kidding. Subscribe.